Hello and welcome to another Media lesson. What's the deal with the lack of timeline in Max? I mean, if you consider Max as some kind of a DAW, which I know some of you will disagree, it lacks probably some of the most fundamental things in a traditional DAW, and it's the timeline. If you open up any other DAW like Logic, Ableton, Pro Tools, Cubase, you name it, you will be presented with a timeline that you can put stuff in it. So in Max, you don't really have a timeline, and the guys from Max actually wrote something about that. I'm going to paraphrase it like crazy because I don't really remember what they said, but they said something like, "We admit we don't have a timeline, but that doesn't mean that you can create your own." And what does it mean? So, there's a plus side and a minus side in Max. The minus side is that you have to create your own timeline. It means that sometimes things that are relatively easy to create in any other traditional DAW seems a little bit harder and requires some work in Max. But the plus side is, and I think this represents really well the entire ideology of Max, is that you get to create your own timeline. In fact, you can create your own timelines because you don't really have any boundaries with Max. Max is actually allowing you to create different timelines in one setup. I don't mean different subdivisions. I'm actually talking about different metronomes, different clocks, and you can work with them simultaneously. So it's pretty cool. You can create your own timeline. So we're going to build a drum sequencer today, like this one from the left, but maybe a more simple version of this one, because building this entire thing in one lesson will take hours. But we're going to create a beautiful grid to display. We're going to solve the mysteries of computerized swing, and we're going to create the option of switching between different time signatures, picking up tempos and all sorts of different things. In this particular one, you can see that there are a lot of fancy stuff. And I think this is what's cool about Max. You can make devices that are entirely customized for your needs. So how cool is that? For example, I love polyrhythm. So I created another line that I call polyline, which allows me to pick up any sounds from my drums here and send it through a different tiny sequencer with different subdivisions to create some cool polyrhythms. I also created this bouncy hat thing, which if you're familiar with my bouncy bits, it's kind of the same algorithm, and it makes the hi-hat jump randomly in different subdivisions, create some kind of a nice randomness. I also like to bring this device on stage and play with different instruments, so I created this autoplay that allows me to play patterns that are stretched beyond a single bar, and every few bars that I choose, I can choose randomly to pick up a fill that I've created. So this is really cool. You can create some really deep and customized sequencers. The one from the right is a melodic sequencer, and we're going to deal with a melodic sequencer in our next lessons. And by the way, in the last few lessons, we created some drum sounds. So I decided to take all these sounds and pack them in one patcher and make them a little smaller and compact. All right, let's load up a new patcher. So let's ask ourselves, what do we want from a drum sequencer to have? So we want to have maybe 8 channels. We maybe want like a 16 steps grid, and maybe we want it to be adjustable so we can choose different time signatures. And what else? We want to create a swing knob. What else? What are the things that we want? We want a beautiful display. And I'm going to show you the secret of creating this cool display that you just saw. Okay, let's start with this. So we need 8 channels. So how can we make 8 channels run and send bang messages. And that's the key here. We need some bang messages that are individual and that are set in time and some kind of a grid. So we can use matrix control, which is, in my opinion, one of the most powerful objects in Max. Okay, so in the inspector, we can choose to auto size the thing so it won't be warped. And here we can set how many channels we want and how many steps we need. So number of columns, we want maybe 16 steps. Number of rows, we want 8 steps. So we have 8 channels over 16 steps. What the matrix is really giving you, let's open the help file. The column, the row, and the value, which goes from 0 to 1 if pressed. And in this side, it's giving you a list of the row or the column. You can actually set it to get whatever you want. Get the row, get the column. This is what you're looking for, and this is what we're gonna do. So for example, let's send a message here, and let's just put some numbers here, and let's put this. Okay, and now we can send a message get column, and let's put string 1 integer box here. So if I move to 0, I will get the first column, and it's counted from 0 to 15, by the way. So you can tell first row and first column, or 0, row number 0, column number 0 will be 0, and then the second row will be 1, and the third will be 0, and so on. So if I pick, for example, the third row, which is number 2, you can tell that these numbers are coming from where I have activated spots and where I have all the other deactivated spots. Now we need something to count this string. So we need 2 objects. The first one is going to be metro, which metro is just a metronome. Here's a very important trick to know. Metronome is expecting milliseconds, and you probably want to count your tempo in BPM. Easy math, you need 60,000, which means that how many milliseconds there are in a minute, divided by the BPM, which give you the number of milliseconds that you need to put here. So how can you do that? An integer box, this will be for the BPM, and we have to divide it by 60,000. So there's a way to do that, because you can't simply do divided by 60,000, because this is actually opposite. So you can put the not sign. So it actually means that it's dividing in the opposite direction. And we put 60,000, and let's put a dot to make it float, and pass it through here. I'm going to also multiply it by 1, and this is later because I'm going to change the multiplication to create different subdivisions. Let's put 90. I like 90. And a toggle to activate the metronome. So if I put a bang here, I should have an activated metronome. Now the second object that we may want to use is a very important object in our drum sequencer, and it's the counter. And let's tell it to count in a forward direction. You can actually choose different directions. Let's tell it by default to count from 1 to 4. And send a bang, and look at that. It's counting from 1 to 4. And you know what, let's change it to 16 because we want to count to 16. Okay, pretty cool. Which means that we can bring it here, and if we put a message here, we'll see that the message is constantly changing because it's just getting the column every count here. Okay? So that's already the basics of creating a good sequencer. So let's also create a cool display. And I'm going to show you a trick of mine that is secret to create a very nice looking display. All you have to do is to copy that. Let's pick up something like that. And let's change the color to something more like a kind of a light. Okay, something like that. That's cool. And we can bring down the background, and we can bring down also the cell color off. So we're only left with the activated cells. And, sorry, let's go back to the inspector. And we want to have only one activated cell per row. So now you can see that I can't have more than one dot in the same row. That's pretty cool, because now I can send a message to set the column number with the row number and to activate it. And I have to copy that 8 times. And now we're going to change the row number. So number 1, 2, and I send it here. Kind of invisible, but you get it. And if I put the counter here, you'll see that it start counting. Okay, beautiful. Now we can put it here, adjust it, and go to the inspector. And also, I would like, let's take it. Also, I would like to bring down the opacity to like 40, maybe. So now I have a display that is running like that. Really cool, huh? So next, we have to select each cell and send a different bang for each row. So we have 8 rows. So all we have to do is to unpack 8 numbers. So unpack 1, 2, 3, 4, 5, 6, 7, 8. And this is pretty much it. Next is to select 1. So every time a number hits 1, it will bang. So let's copy that, and let's copy that, and there you have it. Oh, and by the way, in our light matrix, go ahead to the inspector and also hit ignore click, because you want it to be like a dummy matrix, not something that you can actually control. Let's put it aside here. And let's also bring the message of clear. So we do something like that. And let's bring a bunch of buttons or bangs. And let's try something. Okay, let's see if we do have this motion in bangs. And we don't, because I need to send it from the right matrix. So this is why I moved this matrix to here, so I won't have this problem. Okay. And let's also send the calm message, of course. I don't know why I disconnected it. It's funny. Okay. Oh, yeah. It's coming back. Here, notice something, that it's not counting right. So this is because we're counting from 1 to 16, and this is 0 to 15. So we're going to add -1, okay? So now it's counting from the actual numbers. Really good. So next, we may want to reset the counter every time we activate the sequencer. So all we have to do is to take this toggle and put it here to reset counter to the number on next clock. So every time I start, it will start from the first one. And notice this is from right to left, by the way, in this case. And coming back, and boom. That's great. This is exactly what we need. So we already created a good drum sequencer. So we have 8 channels. We have 16 steps grid, but it's not adjustable. So in order to make it adjustable, this will be pretty easy. Put an integer box, and you can change the last inlet or the first inlet of the counter, which means set count maximum. And let's say we want to create 7 steps. So now we have 7 steps. And if we put our display thing here, you'll see that this is just 7 steps. Okay, so we fix this. We have a display. Let's add a swing. I'm going to teach you how we can swing in computers. Sometimes when we learn about swing, we learn that it's like kind of taking triplets and remove the middle note from each triplet. So instead of having one enda, two enda, one triplet, two triplet, so on, you kind of have 1, a 2, a 3, a 4, which means it's like a shuffle. And in classical music, sometimes you'll see that triplets are kind of just dotted eighth notes followed by 16th note, or maybe double dotted eighth notes followed by 32nd notes. So what's common to all of them is that the first note is being longer than the second one. Or you can say that the second note is being delayed a little bit. So how can we pick every second note? This is interesting. So how can we do that? So we have a great operator in computers called the modulo. Modulo is bringing you the reminders of your divisions in integers. If you divide 2 by 2, you don't have any remain, so you have 0. But when you divide 3 by 2, you have a remainder of 1. So if we do modulo 2, each odd number will give us the number 1, and each even number will give us the number 0. It's very powerful because it allows us to pick odd and even numbers. So let's see if it works. And it does. So we need for the even numbers, and by the way, if I'm taking this modulo and connected to the -1 here, everything was the opposite of what I'm doing. So I would like to select 0. So now when 0 is selected, we're going to get a bang from here. And when something that is non-zero, which is 1, will be banged from here. And we're going to put an object called a pipe, which is a delay for numbers. So you can delay numbers in milliseconds. So let's pick this and connect it to here. So I like the odd numbers, because we're starting in 1 here, to just pass regularly. So every time an odd number is hitting, we're going to trigger the number 0. And every time 0 is hitting, we're going to add a number box. And it can be between 0, which is 0 swing, let's say to 60, which is a nice number. And just bang this. And we just put it in the inlet of the pipe and put the message here. So now we have swing. You can't tell here because we don't hear nothing. So let's add some sounds. So I put this make note just so we can hear something coming out. And because we haven't done any subdivisions yet, and so let's write it here. This is another task we need to do. Oops. Subdivisions. One different subdivisions. So I'm just going to crank it up a little bit so it will be faster. And let's play with our swing parameter here. Whoops, too much. Groovy. Okay, so we have a swing knob. Last thing is to have different subdivisions. And I'm going to show you how we can do that. Let's bring everything here. So all we have to do is to multiply the number coming out from here with a different number. So if you multiply it by 1, it means that it will be just quarter notes or just the BPM here. But we can multiply it by different subdivisions. For example, if we want 8 notes, we can multiply it by half. So let's trigger half every time we select 8 notes. And if we want 16th notes, which is like the basics of any good classic drum sequencer, we can multiply it by quarter. And what about triplets? So if let's say we want triplets, we can multiply it by a third, like that. And if you write a bunch of threes like that, Max is actually identifying it as a decimal 1/3. And let's say I want 6 tuplets. So I can multiply it by this number. Okay. And of course we can go to 30 seconds if you want, which is this. And you can also use divisions, by the way, and it's exactly the same. So you can, instead of multiplying it by half, you can divide it by 2, by 3, by 4, and so on. I think the reason I'm doing multiplication is because if I want to go higher, for example, I can multiply it by 2, and it will be half notes. So this is pretty much it. And you can select 2, 3, 4, 5 things, I think, right? 1, 2, 3, 4, 5, yes. Put whatever UI you want. It can be a menu, it can be a tab, whatever you want. And hook this up like that. And let's, for this demonstration, just put a number box. And let's trigger a bang. Whoops. Let's trigger a bang every time we change the number. So it will send the new value immediately. And you can be more fancy about it. You can choose to change. And this is what I did in my sequencer. You can choose to, every time the counter is ending a cycle, then, hit the new subdivisions, and you keep your metronome sync with other metronomes if you have. And so let's go. See if we have 8 notes, and then triplets, and then 16th, 6 tuplets, and all the way to 32nd notes. Swing. And there you have it. So, of course, every bang here can be sent to a different sound. Right now, I just chose the make note object with just one note to just demonstrate that this is actually working. But, of course, you can send it to something else. So I hope you learned something from this video. And if you like this video, please subscribe for more. And I'm trying to come up with these videos on a weekly basis. And so see you next time. Stay tuned.